Hello everyone, you are welcome back. If you are just coming across our video for the first time, this is the official YouTube channel of Outlier Research and Technology Center. In this video, I'm going to show you how to detect outliers in SPSS using Mahalanobis Distance. How to detect outliers in SPSS using Mahalanobis Distance. Please take note that Mahalanobis is a measure of how far each case in your data is from the average. That is the mean of all variables combined. What I'm trying to say here is that if you have 5 variables that you want to check out the outliers, this particular method will first compute the average and look at how each of the data is far away from the average of that particular group of data. This approach helps to detect multivariate outliers, that is cases that are usual across multiple variables, not just one. So when you make use of Mahalanobis Distance, it will enable you to detect multiple outliers, and that outlier is not only the one that is unique to one of the variables. It's going to be outliers that are unique to all the variables in the computation. So please take note, this particular method is used for data that are continuous. You can't use it for categorical data, and also you must ensure that you check for normality. Please, if you don't know how to check for normality in SPSS, you can check our channel. You will see one of our videos on how to detect normality in SPSS. So this particular method is perfect for identifying multivariate outliers. So if you are doing any analysis and you are concerned that you have issues of outliers, I will advise you to make use of this method. There are certain things that you need to do after you must have computed your Mahalanobis value. The first thing that you must ensure that you do is that you must filter or sort your data by the outliers. I'm going to show you how to do that in SPSS. So when you sort out your data, then you look out for those values that exceed 1 or any value that is 1 in your data. So any value that is 1 indicates a potential multivariate outlier. But take note again, when you see such, you don't need to delete it. You have to review the case. You have to look at it very well. Make sure you examine it before you make your decision on whether to delete it or retain it. And also you must look out for possible error that could be responsible for that outlier. For instance, if you see 1 after which you have computed the Mahalanobis outlier, then you need to check maybe it is as a result of data entry error, or if that particular case is valid. If it is valid, you just retain it, but if it is as a result of data entry error, you can delete it straightforward. So you are not expected to just delete any value that is 1. You must first understand them. You need to study that particular case, if it is as a result of data entry error or if it is as a result of missing value. And also please take note, when you want to use this particular method, you must ensure that there is no missing value in your data. You must ensure that you have all the data. So you make sure that your data is clean, no missing value, and also you use this particular approach when you are dealing with a numeric or continuous data. Please take note, you can't use it for strings, you can't use it for dates, you can't use it for currency, and also you cannot use it for categorical data. So you must ensure that your data is numeric, is continuous, and you don't have any issue of missing value. There are some things that you need to take notes. The first is that this particular approach is used when your variables are normally distributed. I've said it earlier. And also, before you remove any multivariate outlier, you must check very well. So always double check for univariate outlier before jumping to multivariate outlier. What I'm saying in short is that, or what this means is that before you make use of this particular approach, you can use the box plot approach first. Don't forget that this Mahalanobis distance check for outliers that are unique across the variables, not only one variable. So you first make use of box plots approach to identify outlier before using multivariate outlier. And if it happens that you see 1 or 2 cases of multivariate outlier, you can return it if it is valid. Also, you can transform your data to address that particular outlier. Another thing you can do is that you can make use of methods or techniques that are robust to multivariate outlier. This one, I want to emphasize it again. Make sure your data is clean, no mixing value, and also this particular method is used when your variables are numeric or continuous. In case you find one or two outliers in your data and you are concerned that, oh, how am I going to address this or how to deal with this particular outlier, the first thing you can do is to remove them. But please do not remove or delete any outlier automatically. You must examine it. Check if it is as a result of data entry error or if it's as a result of mixing value before you proceed to either removing or deleting it. The next thing you can do is to transform the data. You can take the log of all the variables. The next thing, which is also possible thing, is to windsorize it. So what I mean by this is that when you notice that there is one or two cases of outlier in your data, you cannot look for the next value that is not an outlier in your data. So once you see that value that is not an outlier, you just replace the outlier with that particular value. So you just replace the outlier value with the next highest non-outlier value. So you need to first examine your data. Once you examine the data, you now identify that value that is not an outlier, that is less than 1. Then those one that is 1, you now replace it with the value that is less than 1. And the last one, which I've explained earlier, is to use a robust statistical method. That's what I mean. That's what I said here, that you should use a robust statistical method. So you can just take a look or you search for the techniques of analysis that are robust to outliers, then you make use of it. For instance, if you want to do regression analysis, now you can use contour regression. When you make use of contour regression, it will certainly address that particular issue. So now let me show you how to do this test, or how to conduct this test in SPSS. Let's move right to SPSS. Now this is my work file in SPSS, and here I have both continuous and categorical data. All the variables are numerics. There is no string here. So now we are certain that we can't make a mistake of choosing a string, but we have categorical variable. For instance, sex is a categorical variable. Also job category here is a categorical variable. But I said earlier that you must use a continuous variable or continuous data. So here we have height as a continuous data, we have weight as a continuous data, we have income, we have square root of income, also we have weight here as well. So now we can now make use of height, weight, and income. Weight, and income for our analysis. To compute the Mahalanobis distance, you first need to go to analyze. You click on analyze. Once you get to analyze, you pick regression. Next, you select linear. Please take notes. We are not concerned with the regression results here. We are not interested in the regression results. We just want to use this particular channel or platform to compute the Mahalanobis distance. So now we have identified 3 continuous variables. We have 3 continuous variables. First is height, second is weight, and the third is income, which is current salary. So out of these 3 variables, we are going to make one a dependent variable. Please take notes. If you have done your univariate analysis, univariate outlier test, and you notice that out of these 3, there is one that is so free from outliers issue, you can make that particular one a dependent variable, because the Mahalanobis that we are going to compute, we make use of those variables that are considered to be predictors or independent variables. So let's assume that we have made use of box pilot, and we notice that out of these 3 variables, height, there's no outliers in our variable. In height, then we can make height a dependent variable. Then weight can be taken to the independent box. Also, we can take current salary to independent box. So here we have 2 independent variables or 2 predictors and 1 dependent variable. So our interest now is on weights and current salary. So once you have this, you now need to go to save and select Mahalanobis Distance. So here is Mahalanobis, then you check it. Once you check it, you click on continue. Having done that, the next thing is to click on OK. But let me increase the numbers of independent variables to 3. Let me make use of rent paid by respondents. Let me move it here. So here now we have 3 predictors or 3 independent variables. We have already checked the Mahalanobis tools here. We have checked it. Then the next thing we need to do is to click OK. Immediately we click OK, you will notice that a new variable will be generated. Let me show you the last one, the last variable here before I perform that operation. You can see the last variable here is rent 2018. But once you click OK, or once I click OK here, you will notice that a new variable will be added. So now let me click OK. Take notes, we are not interested in the regression results, so we close it. We just close the regression results. We are not interested in it. Now if you look at the work file again, you can see that a new variable has been generated, and that is Mahalanobis Distance 1. Having done that, the next thing that we need to do is to find the outliers. So now we have already computed the Mahalanobis Distance, but before we can say this one is an outlier, we need to compute the outliers as well. To do that, you now go to transform, then you click on compute variable. Once you click on compute variable, this particular window will open, and here we have target variable, we have numeric expression, and we have the functions. Also we have the variables. So now in target variable, what we'll put there is the name that we want the new variable that we are about to generate to take. What name do you want to give the new variable that you want to generate? Let us assume that we want to name it outliers flag. So you just say outlier, you can just type it in, outlier underscore flag. So with this, we'll be able to identify the outliers traits without doing any other further calculation. Now, how many variables? We need to take notes. The other time I said we are interested in those predictors. So we have 3 predictors. Please take note of that. You know we use 4 variables. The first one is height, the second one is weight, the third is current income, and the fourth is rent. And I said that I want to assume that I've used box plots, and from my box plot analysis I noticed that height does not have any outlier issue. So I make height my independent variable. Now those variables that possibly may have outlier issue, I use them as independent variables, and there are 3 in numbers. So in this numeric expression, what I'm going to put there is the formula that will be used to generate the outliers. Now you need to memorize the formula. Of course, we have different one. If you are using R, you will see another formula. If you are using in fact in this SPSS, there's different way, but the one that I'm going to use here is 1. Take notes, when I was introducing you to this particular method, I said after you have computed the outliers, you now look out for the cases that are 1. Those ones are potential outliers. So now we now make use of the first thing we type here is 1 minus, you can use this screen, 1 minus, then the formula, which is the chi-square distribution. So you click on this, you will see it's there here. Click on this. Once you click on it, you go down, look for the formula chi-square. That's CH chi-square. Let's look out for CH. Okay, I'm still looking for it. I don't want to type it. I believe it should be here. cdf.ch. That's cdf then .ch. Okay, it should be up. Yes, this is chi-square distribution. So this is the formula. You click on the formula and you now click on this arrow up to move it up. Arrow up. Now we already have the formula, but there are 2 other things that we need to add. The first one is the Mahalanobis distance that we have generated, and the second one is the numbers of predictors, that is the numbers of the independent variables. Now you come back to list of variables. This is the Mahalanobis that we generated. You click on it, you click on this arrow, it will move it there. Then here, how many variables? how many predictors or independent variables do we have? We have 3. Don't forget that we use 4 variables. One is a dependent variable, and the other 3 are independent variables. So we put 3 here. Once this is done, then you can now click OK. So I'm going to click OK now. Okay, then I can close this window. Now the outlier flag has been generated. Here is it. This is the Mahalanobis distance, and this is the outlier flag. Now we have the outlier flags. Then we can now review it. Any value that is 1, there is a potential outlier, multivariate outlier. So now let's look at it. Here you scroll down. This is 1. So this is a potential outlier. You notice down. That's case 30 is a potential outlier. You can notice down. Then you go down. Look for another one. So far we have only found 1. Okay, we have just 1 potential multivariate outlier. Now that we have identified that, you can now review. You can now go through the variable again. What could cause this outlier? You check. Maybe it's as a result of data entry error. So you check it very well if it is as a result of data entry error. And if you find that it is a potential, is a real outlier, you can just remove it. You can just click on here, you right click, then you clear. Once you clear, this case will be deleted. So that's the first solution. The first solution is to remove it. But before you remove it, you need to examine it. You need to look at it very well and ensure that it is a real multivariate outlier. The next solution is you can transform all your variables, all the continuous variables. You can take the log of everything. Once you take the log, then you run the Mahalanobis distance outlier again. You do the test again. If you do that, you will notice that we don't have any value that is 1 here. And the next thing you can do, if you don't want to take the log of everything, is that you can winorize it. So now you can do that by making use of the next highest non-outlier value. You can see here now we have 0.97. This is highest that I've seen so far. Let's check whether we are going to see 0.98 or 0.99. No, we cannot even see 9. We can only see 0.98. So you check if there is 0.98 there. If there is no 0.98, that means 0.97 is the highest value. So I want to assume that the highest value here is 0.97. So you can winorize it. And how do you do that? You just replace the value by, you cannot look out for it and replace the value with the, what is it called, 0.97. So everything here, so you just copy this case 37 and replace it. Yes, you copy this case 37 and just paste it here. So you replace it. Don't forget that Mahalanobis distance look out for outliers across the variables, not just one variable. So for height, weight, income, and rent, now you look for the value for 37, case 37, then you replace each with the value for case 37. So that's how to winorize it. And the last approach that you can use is to make use of a robust statistical method. I mentioned one the other time, that is counter-regression. So instead of using ordinary least square or ARDA, you can use a counter-regression because it is resistance to outliers. Counter-regression is resistance to outliers, if I'm not wrong. So you can make use of counter-regression for your analysis. So with that, you are going to get a result that is not biased. So far we have looked at how to test outliers in SPSS using Mahalanobis distance. I've shown you how to compute Mahalanobis distance and also how to obtain the outliers and what values you need to look out for. I've also given you the definition of Mahalanobis distance. Don't forget that I said you can only use Mahalanobis distance when you are dealing with variables that are continuous, and those variables must also be numeric. And also you must ensure that you clean your data. You don't have any issue of missing files. So with that, we have come to the end of this video tutorial. Please, if you are just coming across our channel for the first time, subscribe to our channel, like our video, share it with your colleagues, and if you have any question, you can post it in the comment section of this particular video. Thank you.